Hello, in this video, we will be seeing how to find the majority element in a given input array and also compute the time complexity and space complexity of the solution that we will be building in JavaScript. To reach a solution, we will be using the Boyer-Moore voting algorithm. And before jumping into the solution aspect of it, let us first try to understand what is a majority element. Let's say we are given an input array that looks something like this: 3, 2, 3, 3, and it has a length of n. So in this case, it has a length of 4. What is the majority element is the element that will be appearing more than n by 2 times in the input array. So n is 4, n by 2 is giving us 2. So it has to appear more than 2 times in the input array. Then we can say it's the majority element. So it's appearing once, 3, then once more, and then once more. So it's appearing 3 times, which is greater than 2. So 3 becomes our majority element for this specific input array. And let's jump into the solution aspect of it now, using the Boyer-Moore voting algorithm, which says that we will be choosing one element in the array as our candidate to be the majority element, and we will be keeping a vote counter for that specific element that we choose to be a candidate. And as we iterate through the input that we have received, if we encounter that candidate in your input, we will increment the counter. If you don't encounter the current candidate and encounter some other element, then we will be reducing the counter. So if you encounter, you increment. If you don't encounter, you reset the counter by -1. And if the counter reaches 0, in that case, we will try to choose another candidate to be a majority element. So with this in mind, let's jump into the explanation aspect of trying to go through this array and apply this Boyer-Moore voting algorithm. So first we said is we need a candidate. So let's choose this 3 as a candidate. So we said 3 is our candidate. We start from the input. We increment our vote counter by 1. Then we will move towards the next element in our input that we are given. So we will move to 2 now, and here we will check, hey, what is our element here? Is this element our candidate? It is not our candidate. In that case, what we will do is we will reset the counter to 0 by doing 1 minus 1. As soon as the counter gets reset to 0, we will consider this aspect of our input as a prefix and forget about it, and we will just move forward now. And the next element after the counter was reset again becomes a candidate. So initially we had 3 as a candidate, then the element immediately after the reset is going to be a candidate. In this case, it is also 3, and the counter is 0 at this point. So now what we will do is, again we will move forward our counter by saying +1, because at this point we have our latest candidate that we have selected. Then again we will move the pointer to the next input element that we have in the array. So now the counter will become 2. The counter is 2, and we have reached the end of our input. Because the counter is not 0, that means we have found our majority element from the candidates that we considered, which is going to be 3. And that's pretty much it in terms of the implementation. As we said that we are going to be having a majority element candidate. So I will say majority candidate is equal to 0 just to begin with. And I'm going to return my majority candidate at the end. That's going to be my majority element. I'm also going to keep a track via a counter that's going to just get incremented as soon as you find the majority candidate. If you don't, we are going to decrement it. So I will say, given that we have this nums as our input array of numbers, I will just say num of nums, and iterate through the entire input that we have received. At first, I need to pick a candidate. So when we were here, we picked this candidate, which was the starting candidate, and at that point of time, counter was 0. So we will say if the counter that we have is 0, then whatever current number that you have becomes our candidate. So I will just say majority candidate is the number that you currently have, which at the start of your loop is going to be 3, the first candidate. And then what we are going to do is this counter needs to either increment or decrement. So I will just say plus equals if the number that you have currently encountered in your iteration is the majority element. So if the number itself is the majority candidate, then you just increment it by 1. Otherwise, you decrement it by doing plus equals minus 1. So it will decrement the counter. And that's pretty much it. We just keep track of your counter, and we have a candidate, and we keep iterating through the entire input array that you have received and try to see if that fits the criteria to be your majority element. And as long as we have considered that it will get reset, this example will give us an output of 3, because we said here if your counter becomes 0 at any point of time, then the next element after it became 0. So here in the example, the counter became 0. The element immediately after that will become the next candidate. So first 3 was the candidate, it got reset, then again 3 became the candidate. And that's pretty much it. In terms of the time complexity, it's going to be big O of n, because we have to go through the entire input array to figure out which is going to be a majority element. We cannot just go half the way or something. We have to go all the way. And in terms of the space complexity that we'll be having is going to be big O of 1. Reason being that we're just using 2 counters here. So one is for the majority candidate, which can change, and another is to keep track of the votes against this majority candidate that we have. That's why we call it the Boyer-Moore voting algorithm, because we keep trying to keep a track of this votes against a specific candidate, and if the votes become 0, we just discard that candidate and move on to the next candidate. And that's pretty much it. Thank you for watching. Please like and subscribe.